Section 2 starts talking about functions, and the biggest thing about functions is that they're a special kind of equation, is really what it comes down to. And for that part of it, the very first thing is, I guess here's the biggest thing. Let's go and get a couple of definitions out of the way. Now they give you the blah 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 definition that's in the book, which is great. The biggest thing we got to back up here in a minute and we get a couple of small things from it. They'll talk about a relation, which is not a relationship with whoever happens to be you're in a relationship with, but this is just a big group of order pairs. Okay, so a relation is just a big group of ordered pairs when we go through this thing. They're going to throw out a couple of options when we talk about this. The domain. The domain is basically it's the x values. And then the range, well, that's just all your y values. Okay, now the big fancy definition they give to you about what a function is great, but here's what it really comes down to. Here's the easy version of what a function is. Here's what makes a function a function. Functions cannot have repeated x values. Okay, and for functions, I hate to say that the y values aren't important, but they're really not that important when it comes down to what a function is, because the function basically says, as long as I don't have repeated x values, then this thing's okay. And a function basically is an experiment that you can predict what's going to happen. That if you, and I always go back to the Mythbusters, because I watched them one day, that they had I think it was an old Civil War cannon they were going to fire off. They said this is the one episode that you'll never see that got on the air, because they did all the calculations and did a small set and came up with everything. And they fired off this cannon that was supposed to go half a mile on their little test range they had. It wound up going like a mile and a half, so it went way beyond their test range. So they had to go up to people and go, "Hello, excuse me, I'm sorry, did a cannonball come through your house?" "Oh, it did? It was the house next door? Okay, thank you." And they had and literally it went through like 2 people's houses and then got stuck in somebody's car. And they said that they had to sign up, all these people had to sign off waivers and do all these things. And I was like, that's, if I was in that house, I'm like, yeah, put me on TV, I'm good. Yeah, I made it on Mythbusters. But yeah, they said that one will never make it on air. I'm like, that's the one I want to see. I want to see y'all mess up and, shoot a cannonball through somebody's house. But you're going to put them on TV. How's that bad? I mean, everybody wants to be on, YouTube and everything else. Now it's like, okay, I'm going to put you on TV, and you're not going to have to pay for it. I'm giving you free publicity. But, well, yeah, you got to pay for the damages on the house and the emotional distress that they had of a cannonball coming through their house. Yeah, so yeah, but I still been okay. You're going to pay me $100,000 and you're going to put me on TV. Okay. And so here's basically what it is. A function's like a recipe. That if you go out to a vending machine and you hit the Mountain Dew button, you're going to get a Mountain Dew. And, one time you punch it, you get a Mountain Dew. The next time you get a Dr. Pepper, you're like, well, wait a minute, what's going on here? So a function basically says if you do this thing, you're going to get one answer back. If you push the button and you get this or this, that's not a function. A function says if you get this, you get one thing back every single time. You never get 2 things that you're going to get off this. So that's the part of it that when you're doing the domain, that you're never going to have an x that gives you this answer, or you get an x that's going to give you this answer. That if you give me x and it's a certain number, every single time you're going to get this single answer that comes from it. So it's always pairing one answer up to the x value that you're going to plug in. And the way they'll do this, the way they'll show a couple of these, mostly they're going to do ordered pairs. They used to do some other different things, but I think most of them now they're going to stick to ordered pairs. Is they're going to give you something like this. They'll tell you they'll give you something like this. They'll say, tell if the relation is a function, and they'll probably also at the same time to ask you to list the domain and the range. Okay, and we'll do two different examples just so you can see for sure what's going on with these. So there's the first one we'll do. There's our relation, and again, a relation is just a big group of ordered pairs. 2, 3, 4, 5, doesn't matter ever how many you have. So they're going to ask you, all right, number one, is it a function? And well, probably really that'd be the third option. 1 is going to be list the domain, 2 is going to be list the range, and then 3 would be to say what the function is. So if they ask you to say what the domain is, yeah, just go back and tell me the numbers. We've got 3, 5, 7, and 4. If you want to put them in order, that's great. If you don't, that's fine too. It doesn't really matter as long as you've got all the numbers in there. So tell me what the x values are. Range. There we go. -2. Now, -2, 1, 9. If it repeats like this one does, you don't have to write it twice. If you want to, that's fine. But if you've already said -2, you don't have to say -2 again. So it's -2, 1, and 9. Okay, and again, when they're talking about if it's a function or not, all you're worried about is the x values. Did any of those x values repeat? Okay, so if there's no repeats, then that means it is a function. And again, you only look at the domain to figure out if it's a function or not. The range doesn't really have an impact on it. It's all about what the domain's going to be. Thank you. Okay, so here's example 2. And same thing, we'll stick with 4 order pairs here. Okay, so domain, you've got 5, 6, and 8. Range, we've got 6, 7, 9, and -3. And again, order doesn't matter if you're one of those people and you have to be a little picky about your numbers and you want to go back and put them in order, that's fine. As long as you've got the numbers in there, that's good. And again, the domain is where you have to determine what was going on here. Because, there you go, you've got 5, 6, 6, and 8, so the 6 repeats. And again, as soon as you've got a number that repeats, that means it is not a function. Okay, so if you can just kind of block out, because sometimes people they see something in the range, it looks funny. I'm like, no, don't even worry about the range. Just look at the domain, look at your x values. And if those x values, if you have any repeats, it's not a function. If it doesn't repeat, and there's each of the numbers in there individually, you're good to go. That's all you got to worry about. Okay, so that's the part that they give to you to figure out whether or not just looking at the order pairs is going to be the number you're looking at. Second thing that they'll do is where they kind of, and again, they'll start tweaking things out a little bit on this one, is they're going to give you an equation and ask you, okay, is this equation a function or not? Okay, and when we're going through the functions on these, you're really worried about just a couple of things, really, what it comes down to. Determine if y is defined as a function of x. Okay, and here's basically what you're looking for. There's all kinds of things, again, they talk about in here. But the main thing that you've got on this part, it's more of what it's not. Because there's all kinds of different things that they're looking at. Here's really what it comes down to. You cannot have y squared and really everything else that they look at. I mean, they define. Now, here's what they do for this one. There's other things that pop up later on, but when they're talking about the definition, this first part, here's the whole big thing that they look at, is that you cannot have y squared. And we'll tie that in here in a second to show you exactly what that is. But really, that's the whole thing you're looking at when they come through this part of it. Now, what they ask you to do is they tell you to go back and plug in some numbers and work some things out and do all this other stuff. Don't worry about it. As long as you don't have y squared, you're good to go. So they're going to give you some equations. And you're just going to go through the numbers here. Let's give you one here. And it's one of those things that, again, if you know that one little trick, you don't have to worry about doing all this other stuff that's here. That they'll say, all right, here's example 1. Y is equal to square root of x plus 4. Is y defined as a function of x? Don't have x squared, so, or sorry, we don't have y squared, so yes, that one's good. Okay, x squared equals y plus 4. Yes. X squared plus y squared equals 10. No. That's it. I mean, that's right now. Now, again, it'll change later when we get into chapter 2 because they start adding some more details to it. But for this particular part of it, if they ask you, is y define y as a function of x, that's it. That's all you worry about. If you have y squared, it's no. Anything else, we're good to go. Okay, and then, so now they'll come back to that in just a second, that there's something that ties in with that part of it, and we'll get that here in just a minute. But the next thing that they do is we're going to talk about the actual function notation here. What makes a function, when we're writing it out, what actually makes a function be a function without having to go through and check and do all these things to it here. Okay, let's kind of use this for an example. Let's say we're getting ready to graph some lines, doing some linear point slope or something like that. That when we're graphing these, most of the time you put it in y equals mx plus 3 form. You put the point slope form. So let's say we had something like y equals 2x plus 3. That when they talk about what function notation is, if you have any equations that set up like this, what they're going to do is you're going to replace y with f parentheses x. Now, here's the one catch with this one, if you haven't seen the function notation while. That f parentheses x is not f times x. That in this case, the parentheses is not multiplication. That when we're talking about with function notation, the f parentheses f x basically means that the f stands for function, and x is the number that you're going to use to plug in to solve this thing out. If you were doing temperature, it may be that it's f of t because you're talking about temperature. If you're talking about speed, if you're talking about the rate something's going, it may be that that variable is r. So this f is just the function you're going to do, and then x is just the number we're going to use to plug into this thing. So where this is an equation, where we have y equals 2x plus 3, when you have a function, all we're going to do is we're going to take the y out and replace it with f of x. And then this side over here, the 2x plus 3, stays exactly the same. So all you're doing is just changing that left-hand side where you have the y equals and just replace that y with the f of x. Okay. So when you see the function notation, when they talk about function notation, that's all you're doing. And then they're going to ask you, after they've given you this function like this, they're going to ask you, okay, now that we have this function, they're going to ask you to evaluate it. And with the evaluation on this one, they can say it a couple of different ways, but the big way they're going to ask you to do this is they're going to give you this function, and they're going to ask you to evaluate, and we'll do 2 or 3 different numbers here. They're going to ask you to evaluate f of negative 4. Okay, now here's the big thing that goes with this one, is that especially if you take whatever problem you got, they give you this function, they tell you to evaluate it. If you write it underneath it there, drop it straight down, what you should see is that, okay, where I had an x here, now I've got a negative 4. So now over here, everywhere you've got an x, you're going to take that x out and replace it with negative 4. Everything else in there is going to stay the same. So it's 2 times, and again, this number is in parentheses. When you plug it back in, still leave it in parentheses. Now, here's the one thing that you've got to make sure that you do. When you're working through the functions and evaluating and doing everything that you do on this one, you only work the right side of that equation. The left side is basically just saying, all right, I plugged in negative 4, and this is saying, all right, here's what happens when I plug in negative 4. Here's the answer I'm going to get. So when you're working through this part of it, the left-hand side is just the notation part. You only work the right-hand side of it here. So 2 times negative 4 is negative 8. Negative 8 plus 3 is negative 5. And that's the answer that you're looking for. Okay, and most of the time with these, I think they'll probably give you a part where you're going to answer, 2 or 3 problems from the same function. So if we take this one, part B, they'll probably give you another number. They may tell you to find f of 10. Okay, and again, same thing. Now we're going to take x out and replace it with 10. So on the right-hand side, we'll do the same thing. We're going to take the x out and replace it with 10. So 2 times 10 is 20. 20 plus 3 is 23. Okay, so it's the exact same thing we were doing back in section 1. You're just plugging in a number, doing order of operations. The only difference is that instead of them saying plug in x equals 2, now they give you this where you're going to find f of 10. But it still means the same thing. You take 10, you plug it in, you work it out, you tell me what the answer is. Same setup as you're going through everything there. It works out the same way when you're going through this one. The only thing that might change just a little bit, and this is where they're going to let's go with x squared minus 2x. Okay, so let's say we're going to find f of negative 3 first. Okay, and then same thing. Everywhere you have an x, you're going to take the x out and replace it with negative 3. So over here, again, take the x out, replace it with negative 3. And because that, and I always tell people, that number is in parentheses. When you plug it back in, leave it in the parentheses because that's still the same thing we're doing back in section 1. The squared was part of the original problem. The minus 2 was times the original problem. So now you've got negative 3 squared. Well, negative 3 times negative 3 is 9. Negative 2 times negative 3 is a positive 6. 9 plus 6 is 15. Okay, now here's where here's where they really pick up on the algebra part of what we've got to do, because this is the first. Everything else has been plotting points and just doing order of operations. Here's where they're going to give you one where it's going to change just a little bit. Let's take that same function we had there, and instead of just giving you a number to plug in, they're going to give you x plus 3 maybe. X minus 1, x plus 7, something like that. They'll give you, instead of just a number, now you've got this expression you've got to plug in. And it's still the same thing here. Everywhere you have the x, you're going to take the x out and you're going to plug in x plus 3. I had the squared here, the minus 2 there. Okay, now here's where the fun kicks in. If it's x plus 3 squared, you've got to remember that that means that's x plus 3 times x plus 3, and that is doing the, everybody remember? And that's doing the full method. Oh, I have to clarify. Depending on where you're from. If you're from if you're out in the country, it's the FOIL method. If you're from the city, it's the FOIL method. So whichever one you did growing up, we'll go through that one. Basically, it's the double distributor property. Outside, inner, last, first, last, all that stuff. You're doing x times x, then x times 3. So x times x is x squared. X times 3 is 3x. And then you have 3 times x, and then 3 times 3. Okay, so now when we do the FOIL method through this one, the two middle two terms should go together. So we've got x squared, 3x and 3x makes that 6x plus 9. Now here's the thing you've got to make sure of. Don't forget about the back end of this one, because you still had this negative 2x, or negative 2 times x plus 3 back here. That you've got to do distributor property with that negative 2. So it's negative 2 times x and then negative 2 times 3. So that's a negative 2x minus 6. Yes, sir. Go ahead.
You can't subtract
Yes, you got to do all the parentheses work first. So that you're basically back to that order of operations that you've got to get all the parentheses gone, and then once you've gone through that, then you can go back and take care of everything else. Okay. So, and then from here, what you have is you've got some like terms that you can go back and do. You've got a plus 6 and a minus 2. So if you do 6 minus 2, that'll make that 4x. The x squared. Yep. And then the last piece you've got here, you've got a plus 9 and a minus 6. So if you do 9 minus 6, that would be a plus 3. Okay, and to me, that's the first time where they actually go back and start picking up the algebra concepts and going through. Everything else, you've just been plugging numbers in and kind of working it out, doing order operations. When you get to the evaluating functions on this one, that's the first time where they actually make you go back and go through your algebra concepts of doing the FOIL method, combining like terms, and they bring it all back in there to kind of go through everything. Okay, so, but that's still function notation. Again, the difference is when you have the x. Now, sometimes it may not be that complicated. Sometimes it may just be you're just going to plug. Sometimes it's just the green part of the answer back here. You'll plug it in and you'll do a little distributed property and you're good to go. But, let's just show you what it could be if we're going through this thing, just so you can kind of realize everything that's happening there. Okay. And then, all right, so next thing we've got, now here's where, they're kind of leading into some stuff, but they're not really getting everything that they need here. They're going to tell you that you've got, I'm just going to go ahead and show you here. They're going to give you two different functions that's here. And they're going to ask you to describe how the graph of one is similar to the other one. But again, here's where they're kind of jumping the gun to me just a little bit on this thing. They'll give you two functions. Here's f of x, here's g of x, here's what they are. And they're going to ask you to select some integers, plug it in, work it out, graph those two things, and then come back and tell me how is the graph of g related to f. Mm-hmm. I know what they're trying to do here, but this is one of those things where that they could have done this differently and still had the same thing on this one, because, again, where we get in section 4 and 5, you're going to look at this and go, oh, well, this is all we did, and we're going to be fine. Here's what I would do if it was me on this one. Now, if it's something that you don't know, this is where if it's something that you're not really sure about it, exactly what it is, what they want you to do for this one, and I'll kind of give you the long version of it here, if we can. They want you to go back and take f of x, go back and plug in like -2, -1, 0, plug in 3 or 4 points, get the graph of it, then do the same thing for g of x, plug in the exact same points. Plug in -2, -1, 0, come over here for g of x, do the same thing, plug in the exact same points. Graph those two things and then go, okay, what happened to go from this graph to this graph? When we get to section 5, you're going to be able to do this in about 2 seconds when I have them do the graphs. Because this is basically just like a y equals mx plus b kind of thing. That if you were to graph this one, you would have a graph where your slope is -2. And your y-intercept is you don't have anything, so your y-intercept would be at 0. Because there's no b value back here. This one, your slope is -2. But your y-intercept, your b value would be at -1. So then they're going to ask you, okay, well, what changes when you take this graph that's got a slope of -2 that crosses at 0, if we just did a real quick sketch of this thing. Let's say we did this graph of f of x right here, we did this one red. This would be a line that would look something like this. If we did g of x, and just graph that one real quick, just do a real quick sketch of it, it would be a graph that would look something like this. And that's all right. How did we get from here to here? We just dropped everything down one, right? There you go. There's your answer. So all you're going to do is basically is that here's what you got to recognize. You don't have to do all these things it's going to ask you to do. Just look at the equation and just tell me what's different from this equation to this equation. I subtracted 1. Okay. Then I dropped everything down 1. That's it. That's all you got to tell me. So they get you this idea. They go through all this stuff and try to give you all these things, and they try to make you do all this stuff when really you just look at it and go, oh, I just subtracted 1. Okay. You subtracted 1. There you go. There's your answer. So, sometimes they try to make these things sound really hard and really complicated. And it's like, no, just say the answer straight just like it is. Let me check one thing real quick. Because this is one of those, I know what the answer is, but I'm not sure exactly how they wanted it. So, give me 1 second. Yeah, so here's the answer they wanted. The graph is shifted 1 unit down. Okay, you subtracted 1. You dropped it down 1 unit. So if they don't make you graph it, now if they make you graph it, obviously you're going to have to go back and graph some points and plug stuff in. But at the end, the answer should be, this is one that hopefully will be multiple choice. They kind of give you some options on this one for the graphs, what it looks like. But they try to do all these big things to it and just tell me, no, here's what they did. They went from this graph to this graph. They subtracted 1. We're dropping everything 1 space down, 1 unit down. And that's all you have to kind of realize when you're going through this. That they're just going to have you add or subtract. If you add, you're going to move it up. If you subtract, you're going to move it down. That's all you've got to worry about. So they make this thing sound really big and complicated. It's not. Just y'all have heard of the KISS method, right? Yeah, keep it simple, stupid. They try not to do that sometimes. So I try to say, okay, here's the easy way. They give you this. Let's just keep it simple. Here's all you have to do. And we're fine. Okay. Now here's one thing that they do. It's kind of more review than anything else on this thing. And again, this is more, they're previewing really what we're doing a little bit later on in the chapter. So because we haven't done anything with square roots yet. So they kind of start throwing some more graphs, some more things at you here. If you have to graph square roots, now they're going to give you some numbers. We'll do something like this. They'll tell you to evaluate x, and they'll give you 0, 1, 4, and 9. That you have to go back and basically kind of do the same thing on this one. Square root of x, start off by plugging the numbers in. Well, you have square root of 0. That's 0. Square root of 1 is 1. Square root of 4 is 2. And then square root of 9 is 3. Okay, if they ask you to plot the points, again, it should still look basically the same on this one. That I don't think they're going to make you connect the dots because that's more of what we're going to do in sections 5 and 6 when we get there next week. That if you went back and put all these points on the graph, here's 0, 0, here's 1, 1, 4, 2 would be somewhere about here, 9, 3 would be somewhere way over about here. And again, all they're trying to get you to do on this one is to realize that when we start graphing later on these ordered pairs, if we did connect the dots, this would be a graph that would look something kind of like this. Now, they're not going to make you do that at this point. We'll just get the dots in there just so you got some practice. More practice with plotting the points in the ordered pairs to get you there. And they may do the same. Go ahead, question. That basically whatever your answer is here, when they give you, because this is f of x equals square root of x, that when you start graphing these, you've got to realize that really, even though that's f of x, that's really a y value. Because f of x, all the function does is takes the f of x out and puts it in place of the y. But if you graph it,
yeah, I'm sorry. I
that's okay. Yeah.
For a second, I was looking like you were solving for the x.
Gotcha. Okay. Right. Okay. Yeah. The f of x and y are interchangeable. You can flip flop. They flip flop back and forth on those when they go back through that. So, okay. You've got the numbers here. Now, they'll do the same thing just like we did on the first part here. They're going to say, all right, well, how does that compare to the graph of g of x equals square root of x plus 1? All I'm doing is I'm going to take this same graph, I'm going to scoot everything up 1 space. So instead of this being at 0, 0, now this is going to be at 0, 1. Instead of this being at 1, 1, now this is going to be up here at 2. So this being at 2, now it's up at 3. Instead of this being up at 3, now this is up at 4. So same thing. You don't have to go back and plug in all these numbers. Just realize that all I'm going to do is take this graph that I have here, and I'm scooting everything up 1 space because it was plus 1. If it was minus 1, you would just drop every point down 1 space. That's all you have to do. So, again, sometimes they try to make this more complicated than what it is. Just realize that as long as this number is on the outside of the function, on the end of it, and it's not inside this part of it, you're just going to take this thing and move it everything up and down. So that's all they're trying to get you to see when they go through the middle parts. Okay, and then the last big thing they do with all the function parts is here. Is they're going to give you some graphs, and then they're going to ask you to use the vertical line test. For functions. Okay, now here's where you can be an optimist or you can be a pessimist, and we'll throw both of them out here. So with the vertical is basically any amount of, you can draw a line. So you can draw a 1, you can draw 100, doesn't matter. Anywhere you can draw a vertical line, go back and draw a vertical line through it. If you can only hit the graph one time with every vertical line that's in there, it is a function. And this is one of those where, again, you can kind of go either way with this one. If every vertical line intersects the graph once, it's a function. So there's your optimist. If you want to be an optimist club, and okay, here we go. It only hits the graph, only hits the line once, it's a function. If you want to be a pessimist, you can say it this way: if any vertical line intersects 2 or more times, then it is not a function. So it's just ever how you want to read that in your mind. It's the same thing, just optimist, pessimist kind of thing. It's just whatever one clicks for you when you're going through this thing. And this one is really pretty straightforward. They're going to give you some graphs, and they're going to say, okay, here's a graph. Is that a function? No, right? Because you go back and draw a vertical line right through here, hits it twice, it's not a function. There you go. Here's another graph. Draw a vertical line. Doesn't matter if you draw it here. Doesn't matter if you draw it here. Doesn't matter where you draw it. No matter where you draw the vertical lines, they're never going to hit it more than one time. So you're only hitting that graph one time. So that one's a yes. Okay, now here's when we go back to the whole y squared thing. When they said, what defines y as a function of x. Here's why y squared doesn't work. If you actually went back and graphed y squared, that's what the graph would look like. So that when you do that, as soon as you drop that line anywhere back here, you hit it twice. So, not a function. Okay, now, and here's where it ties back in with that very first definition we talked about, it having the two values. If you draw a vertical line through it, if we went back and put an x and y, let's say that was an x and y axis that we had here. If you went back and put an x, y axis on this thing, let's say you hit here and you hit here. This point would be like at 0, -4. This point up here could be at 0, 6. So what's the same in that? They both have the same x value. That one time you get 0, 6, or it could be at 0 and it's -4. So there's where they try to tie all that together. That if you have that y squared value, then you get that option where you have two different values for plugging in the same number. Then you get that OR statement from picking off the parts there. Okay, and then everything else, they throw a couple other little graphs at you and have you play around with some numbers. But it's pretty much just looking at some graphs and playing around with some things there.